question 2. The question says that before the question statement is drawn, two identical negatively charged spheres A and B, both with a mass 0,15, both of them having the same mass according to the statement, hang from the same point by thin inextensible string, which means that the mass of the string can be ignored. Electrostatic force between the spheres caused them to move 20 millimeters apart. The angle between one of the silk threads and the vertical is 6,99 degrees. So the first thing that we should do here is to get rid of the 20 millimeter, convert 20 millimeter into meters because you are working with the meters. And then the second thing, convert the mass into into kilograms, because automatically is in grams. So the first thing here that we're going to do, we'll convert the mass. 0,15 millimeter is equals to not millimeter, sorry, grams. So which means we are going to say that since it's in grams and grams to kilograms, we divide by 1,000. So 2 kilograms is going to be 0,015 divided by 1,000. So which is going to give us a lot of numbers in commas. So those lot of numbers in commas, we are now going to consider them as in this way. Let's see, 0,15 divided by 1,000, which is equals to 0,00015 kg. So we can use it later, but let's convert it in that way. The second conversion, we are converting the 20 millimeter into 20 millimeter into meters. So into meters, 10 millimeters equals to 1 centimeter, 100 centimeters equals to 1 meter, therefore 1,000 millimeters equals to 1 meter. Then we divide again by 1,000. So dividing by 1,000, which is going to be equals to 0,002 no 0,02 on my calculator, 0,02 meters. So which is 0,02 meters. Okay, so 0,02 meters, which is the distance between the two spheres or the two charges, charge A and charge B, accordingly, or as it is given. Okay, we remember we haven't calculated any question, or we haven't read any question. We are just working with what we have so that we can see what is usual. Then the next thing here, before we do anything, we can find the free body diagram on each and every block. The free body diagram, I used to tell people that when we draw the free body diagram, look for, if you are looking for block A, just draw a point, a big point on block A, and then draw the forces acting on it. We see that the inextensible string, if these are hanging, they're supposed to hang in this direction, which means it's gonna be sphere A this side, and also we're gonna be having sphere B on this side, according normally. But now they are far apart, so which means there is a force applied on it. So which means force applied on it is going to this direction. So what do I mean is going to this direction? Yes, that's where we see the sphere is. So it's this direction. And then if the force applied is on this direction, it means on a free body diagram, we're not going to draw the force applied on that way. We're going to draw force applied in this direction. So this direction is where the force is applied, which is our force applied. Or someone can just put F as it is. And then against the gravity, perpendicular to the gravity. Is Fg. And then this is a string, so the string, it will represent the tension. So this is going to be the free body diagram of sphere A. The same diagram is going to be on sphere B. Sphere B, the force is going this side, applied is this side, and then the string is going up, which is tension force, and then the gravity is going down, which is Fg. So you can see that this is how we see it, or this is how it's supposed to be. Okay, going further, what else can you find here? Let's see, so that we can find all the forces acting on the block A and block B. Since are the same thing, we'll just use one. So the first of all, what you must need, you need to draw a triangle that is now simple to each. So I'm going to draw a triangle here, this line, the green one, and also this line. And also I'll just specifically start with A. So I will make my 90-degree angle on the perpendicular on the two lines. Okay, now I'm sampling this triangle on a separate sheet so that you can understand. Now this is the line, and then let me use different colors so that I can talk about the colors in future. Then this is the line, let me use the yellow, and then this is the other line. Okay, good. Now let me just use the perpendicular for the graph, sorry, for the angle. Now this is our 90. Accordingly, here is where the sphere A is, and then here is where the gravity is supposed to act. The gravity is acting where? From this point is where the inextensible string attached, and then the force of gravity, if it's attached from here, it's supposed to go where? It's supposed to go down from where it is attached. So which means this side now it becomes our Fg. And then if the block A is going to be here, it's supposed to be here according to the diagram. Remember here, if you still remember here what I talked about, or why it's supposed to be here and why it is here, you will now understand what I'm talking about. So if it's here, it means so now the force applied here. The force applied, it is from supposed to be on this point, it's supposed to be on this point, but now it is moving, it is moved, or it has moved to this direction. So which means now the force applied is on this side. And then again, the strength that is attached supposed to be coming from here and coming this side, but now it's no longer here, but then it's from where it is attached and then to where the sphere A is. So which means the tension is on this side of a triangle. Now this is the important thing when you see the drawn structure in this way. So which means now according to the given information, our angle is on this side, on the upper side, which is 6,99. 6,99. I'll just try to draw 6,99 here, even though I cannot draw it nicely, but 6,99 degree is up there. Now let's choose the side of opposite and adjacent. Now the first thing of all, look for the angle of 90 degree where it is, and then the line in which the 90 degree angle is, and where we see we're going to be having the angle that we'll be talking about. That line is going to be the adjacent line, or it's going to be the X line. So the line we're talking about on my graph, or sorry, on my diagram triangle, it is the X line, which is the green line. So if you see the green line will represent the X value on the graph, so on the right angle triangle. And then the yellow line is going to be representing Y. It's going to be representing Y. And then the blue line is going to be representing R, which is the radius. Remember, it's a theorem of Pythagoras. That is why I said to my learners that before you can understand physical sciences, let us start with mathematics, and specifically trigonometry, because a lot of things we do them in trigonometry, we construct, and then we do whatsoever we solve. So maths is related to physics 100%. Nobody should lie to you. No one can do physical sciences without doing mathematics. So it's going to be easy for each and everyone. Now in this way, which means now we can simply say that on the given one, we can say angle is given here. We can have Fg, we can have force applied, we can have tension. Okay, now which means I'm done with elaborating this one. So if you are a clever learner, you understand this topic very well, you already know what to do. And then the first question, they say define Coulomb's law in words. Defining Coulomb's law in words, you will just have to you'll just have to use the the definitions. We have a manual for definitions, or you can use the what is it, the exam guidelines have all the definitions. So which means that every one of you must be knowing these things. It's a must for you to know these things so that you can understand. You cannot understand something without understanding the definitions and its formulas. So definition specifically is just a formula. You can draw the formula as it is, it becomes a definition. So the definition of 2.1, there it is. The magnitude of electrostatic force exerted by the 2-point charges on each other is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. So this is just a simple formula, which means it's a simple formula that says, okay, now the force that is exerted, which is the electrostatic force, it is having the constant, which means how many charges are there. If it's 2 charges, we will put 2 q's, q1 plus, so multiply by q2 divided by r to the power of 2. This is what they're talking about here. This is the formula, and this is what they're talking about. So specifically, just wrote the formula, and then that is it. But we don't want definitions, you drawing the formula. No, don't write the formula, just define it as it is. The second question, draw the throughput diagram. I have shown you how we draw the throughput diagram. Drawing the throughput diagram is going to be simply saying that the point, which is the point here, and then we will have the force of gravity, and then we will have the applied force, and then wrong direction. Sorry. Has to be perpendicular to this one. The force applied, and then we will have the tension. So tension, it comes from this way. So if you can take this one, we can still come back again from this point here, this point here. If you remember here, we drew the throughput diagram before at the beginning. So this is our throughput diagram the way it is. So our point A is here, and then which means our tension is going to be up here against it, back down there, which is the gravity, which is Fg, or someone can just say weight, and then this side is the force applied. Some of you write F, some of us we write Fa. This applied to this direction. So some of you can put the arrow signs, it's still correct. You cannot put the arrow signs, but we advise you to put the arrow signs showing the directions where the forces are going. Good. Okay. The second thing, calculate the magnitude of the force to the of the force to the left on A. So force on A, the first of all, we are having tension. This is our tension. The secondly, we are having the gravity, and then again we are having Fa. So the first that we can find here is the gravity, because gravity is just the ma. So which means now our force of gravity, we're gonna start by saying Fg is equals to mg. So mg, which is simply equals to mass. We converted mass into the other one, which is 0.00015 multiply by what is that one, which is 9.8. The answer is going to be on my calculator. The answer is going to give me 0.00015 multiply by 9.8, which is going to give me 0.00147 newtons. Forces are calculated in newtons, or simply can someone say convert this number in the bargain? What is that thing? Scientific notation: 1.47 multiply by 10 to exponent of, I don't have exponent of this one, exponent of -3, because the numbers after the commas, the zeros after the first zero, there are 2, so zeros are 3 in total. So this is what is going to be the first solution on our force. This is our first solution. Okay, on the first solution, I'll just put it somewhere here. Okay, after putting it somewhere here, okay, I'm having a problem with this one. Let me just put it aside. Just hold on a second, I'm coming back. Okay, good. Let's continue. I was doing the backup video for instead, if this one can run away. because I'm having challenges with these programs. Okay, going further, we now first find the force of gravity, now which means our Fg is equals to, so this side on our triangle, we fit our triangle, don't forget that we are working to fit our triangle. Our Fg is 1,47 times, I'll just write times 10 exponent of minus 3. I'll just put minus 3 so that you can understand why I'm putting that one, because of some of you, if you just get into details without understanding, you just start to say people are just writing. So Fg is equal to, at this point we found it, so we can just put it with the magnitude of it. It's 2. Okay, so this one is going downwards. Okay, but then it's not the final answer. Then now afterwards, if you find this side, remember the question was saying look for the force applied. So the force applied on our triangle is this side, which is side Y. So according to the way in which we are working here, we can use our triangle, and our triangle is going to help us in the form of saying that we are having Y, we are having X, and then we are looking for the Y, and the angle is there. So which means we can use tan. Simply we're going to use tan, yes. How can we use tan? Remember, you cannot understand this if you don't understand mathematics. So tan 6,66 is equals to y, which is f, over x, which is fg. Okay, substituting, which is equals to f divided by 1,47 times 10 exponent of minus 3. Okay, that is the first answer. And then when I will cross multiply, I will have tan 6,99 multiply by 1,47 multiply by 10 exponent of minus 3. So the answer, which is going to be equals to force applied, and then the answer on this one, which is going to be equals to, let me just say tan 66, which is equals to 0,00018023288. Okay, simply sorry, it's Newton. Simply in decimal, sorry, in what is that, in scientific notation, the force applied is going to be equals to 1,80 multiplied by 10 exponent of, how many zeros are there? 1, 2, 3, 4. There are 4 zeros, exponent of negative 4. 4 donkeys, no, 4 newtons. So this is going to be our force applied. So which means it's now answering the question 2.3. It's now answering question 2.3. So 2.3 is answered in that manner. So yeah, that's where is the answers for 2.3. There we are. Let me just highlight with red so that we can see what you are talking about. Hey Moses, I'm finished. Where's the color?